All right. This doesn't project because it's going straight into the podcast or wherever we are out there in cyberspace. Welcome, everyone, to the first lecture in the Water Institute's 2016-17 WaterTalks lecture series. And today we are honored to have Professor Dr. Mr. Pieter van der Zaag, who's going to speak to us about water storage, nature-based solutions for resilient communities. And Pieter and I, we go back, I was thinking about this actually, that we go back 19 years, which means that when we first met, you were just a kid. I mean, and I've never thought of him as a kid because he's so serious and full of big ideas that he's always been the way he is, that you'll find out today. We welcome you back to the Water Institute also because you were here in 2012 as part of a seminar series then, and it's good that you're back with us. Pieter, for those of you who don't know, but will soon learn, explores the dynamic relationship between, his research explores the dynamic relationship between social and biophysical processes when managing water. His research focuses on things such as agricultural water management, allocation, questions about equality and inequality in allocation in catchment areas, management of transboundary waters. He's conducted research and done trainings, extensive teaching and research around Latin America, Asia, and Africa. He's currently a professor of water resources management at UNESCO Delft, UNESCO-IHE in Delft, and also at the Delft University of Technology. When I met Pieter in 1997, he was teaching at the University of Zimbabwe, so he spent 10 years, 1993 to 2003, at the University of Zimbabwe. He has a PhD in irrigation management concerned with Mexico, and he published that PhD in 1992. How do I know he published it in 1992? Because here's his PhD thesis. And Pieter gave me a copy of this, I don't know why or when, but it's called Chicanery at the Canal, Changing Practice in Irrigation Management in Western Mexico. And so I think the operative word there is chicanery, which suggests the social matters as much as the biophysical or the natural in any kind of water management processes. Pieter is also published in a wide range of journals, some of which are rather obscure, like this one here, which you can't even get online yet. The Georgetown International Environmental Law Review, where Pieter and I published a paper on river basin security, theory and practice in the Pungwe and Save river basins back in 2009. He's never received any of his copies, so he's here today, and I'm giving him 10 copies so that he can that he can now dispose of as he sees fit. Okay? So without further ado, thanks so much for being with us, Pieter. The floor is yours, and could you all give a nice warm welcome to Pieter van der Zaag.
Thank you very much for such a warm welcome. I first of all want to thank the staff of the University of Waterloo for their hospitality. It has been really very nice to come back here. I feel very much at home. Thanks to, of course, Kevin and Mark and Simon and Bruce and Mary Ann and Amy and, of course, Roy and Larry, and I must have missed out a few. I also, of course, want to thank the RBC because I happen to be the RBC fellow. So it's not the Royal Bank of Scotland, but it's the Royal Bank of Canada, but the R refers to the same person, I guess. And I'm very grateful to have been able to participate in what I call the Grand River Safari, which was very nice. So thank you for that opportunity to get to know another catchment area. I didn't know Canada water very well, and now I know it a little bit, and it was very exciting. Okay, before I start my lecture, I want to declare my biases, apart from being male, white, old. Three more biases. First of all, I used the word resilient only to attract you. I'm not going to talk about it. The second is my bias is for Africa. And I know that here there's a lot of focus on Asia, but I'm focusing, unfortunately for you, on Africa. And I have a bias for agriculture. So with these declarations, I think I can now start my presentation. So this is a bit the outline of my talk. I start with saying something general about water storage. I look at conventional water storage solutions. I talk about uncertainty and planning in a very uncertain world. And then I would like to focus on a solution for nature-based storage. And then I introduce the term adaptive investment pathways, and then I will make some reflections. I hope I can do this in half an hour, but this is the first time that I give this presentation, so I don't know. So bear with me. Why do we need storage? This is a graph from the airport Met station in Harare, and it gives for 9 consecutive rainy seasons the rainfall in decades, 10-day rainfalls. What you see is, of course, that there is a huge variability in availability of rainfall. Because of this variability, we need storage. And we need farming systems that can deal with all kinds of different type of rainy seasons. You see that each rainy season has a different signature. And we need to have farming systems that are able to cope with this. Storage is critical for that. This is another graph. This is from Tanzania. And here we see that there is a trend, but not statistically significant, that the rainfall over the years from 1960 to 2000 is changing, but it is not statistically significant. But what is significant, that the number of long dry spells that occur in the rainy season is increasing significantly. And that is, of course, a very important feature for our farming systems that may really put a burden on the crop yields, for which we need storage. Storage is, according to some, this is David Gray, ex-World Bank, now Oxford. He introduced this idea that we need more storage. This is a graph from Ethiopia, and let's say the egg colored, what is it? The curry colored stuff is the rainfall variation over the mean, and the other lines are basically measures for the GDP. Now there appears to be a one-to-one relationship between rainfall and GDP in Ethiopia. And David Gray says this has to do because Ethiopia does not have sufficient storage. And therefore this country is at the whims of the rainfall. If there's a good rainfall year, the economy does well. If there's a bad rainfall year, the economy does very badly, which also happened this year. I'm not saying that it is entirely true, but that is what the World Bank used when he was still working for the World Bank, David Gray, to push for more storage. Because at that time, there was some aversion against development and investment in storage. Sorry. We are water storage dependent. This is a graph from a relatively recent publication, 2015, with a very cryptic description. Please ignore it. But the darker the fields, the more those areas are dependent on water storage for their society. And this is a graph which indicates where new storage is required. And these are very big amounts if you look at the units. And then a recent World Bank report says, globally the stage is set for a tremendous and unprecedented increase in the number of dams. Now here I take issue. If they would have said we need to increase storage, then I would have agreed. But here they already jump to the conclusion, you need storage, you need dams. Which numbers are expected to swell. We have to conceptualize storage. And that's what we did in an old paper with Professor Juita Gupta, my colleague at the university, now with the University of Amsterdam. But at that time, she was a colleague of Professor Roy Brouwer at the VU Amsterdam. Fortunately, she's also one day a week at my institute, UNESCO-IHE. And we then made a very simplistic way of trying to make some order in what is storage. Let's define 3 types of media in which water can be stored. The unsaturated zone, the most important store for agriculture. The saturated zone, which is aquifers, and of course above ground storage in terms of tanks, containers. And what is the source? It can either be rainfall or surface water. Now you can fill these boxes, all of them, and then the solution of dams is only one of the 6 possible options. And yet we seem to be very much fixated. If we talk about storage, we talk about dams. So this is another publication, Matthew McCartney from the International Water Management Institute. He also tried to conceptualize storage. You have reservoirs, but that's not the only solution. You have ponds and tanks, you have aquifers, soil moisture, and natural wetlands. And then there is a new graph from my colleague Charlotte de Freiture. She's professor in irrigation at my institute. And she is also distinguishing different types of storage, focusing from natural infrastructure to the built infrastructure, let's say the hard infrastructure, the green infrastructure, focusing also on the groundwater and surface water. And you can see that these distinctions between built and natural and ground and surface water are not entirely discrete. They are a gliding scale. And I think we come back to this. Now, let's first focus on the old-fashioned way of doing things, large dams. You recognize this dam, Belwood. This is a dam in Madhya Pradesh, one of the oldest in Madhya Pradesh. This is the Maguga Dam. This is Cahora Bassa in Mozambique. And this is in Swaziland. You know this expression? 1954, dams are the temples of the 20th century. And it was this modernization thinking that India needed more dams. And at that time, that was the solution. Now we know that we even start to think about decommissioning some of the dams. And we have had discussions about this last week during our safari. So here, large dams. You can take, this is from a source, Lehner. So he has many graphs. I just took the graph for North America, and you see that all the black symbols are dams, and it indicates how much the different rivers are being regulated. It's tremendous. I'll give you another example. This is the change in discharge. Can you see this? The color is not very clear. It's supposed to be red. So this is an interesting graph. It says how much of the discharge is changed due to water withdrawals and reservoirs. And you see that all the darker areas are really very much modified. So you see, for instance, parts of India, Pakistan, Iran, the Aral Sea basin, parts of China, but also, of course, parts of North America, USA, are very marked. What is an even better indicator? How much of the low flow in these rivers have been changed. And you see that they are really very significant in many parts. Yes, the picture becomes even more pregnant. So we see that that dams have really modified many river systems. And there's many publications about this. Also about, for instance, the aging of water, of river water due to reservoirs. Now, and this is my favorite graph. This is the Nile, downstream of the High Aswan Dam. You know the High Aswan Dam in Egypt, yeah? Now, imagine, this was not a graph of a river flow, but this was the graph that I have when I'm in the intensive care and they're checking my heart. What do you say about the patient? The patient is in dire trouble. And this is not just a funny remark. You know, the natural flow fluctuations and the medium in which this river exists have co-evolved over the ages. Yeah? So the river fluctuation and the morphology and everything around it, they are knit together and they are linked together. They have to be like this. If you now change this, you may expect surprises. You may expect that other things will change as well. And that's actually what is happening. What you can also see is that the Aswan Dam is expensive in terms of water, because the total amount of water that is available for Egypt is the amount, it's the area under the curve. Yeah? And you see that there is now less water than there was. Why? Simple question. I'm not going to continue unless I get an answer.
Evaporation?
Yes. How much? Perhaps 15%. So Egypt is prepared to pay a 50% fee for its independence of water. It doesn't want to be independent from Ethiopia or Sudan. It will have to have its own dam. We know that if the dam was upstream, in Ethiopia the evaporation losses would be much less, because first of all, the shape of the gorge of the Blue Nile is much more efficient, so the area is much less, and then also because it is higher, the temperatures are lower, evaporation losses are much lower. So Egypt values its independence, water security, at least 50% of its water. And that's quite a lot if your whole country has depended on the Nile waters for the last 6,000 plus years. And that's the discussion we are having, and that's actually some of the papers that one of our PhD students that I have together with Professor Roy, that we are talking about. Okay, so large dams have large impacts. And I'm now trying to be neutral. Yeah? They have large impacts. They can be positive and negative. They definitely have sometimes very large positive benefits, economic benefits. But they also have large societal, ecological, sometimes geopolitical, and other types of impacts. Positive, but oftentimes also negative. And we have to think about these things. What is the typical characteristic of a dam? You could argue that it is a hard infrastructure. It's not soft. It is instantaneous. You have the dam or you don't have the dam. You can't have half a dam. Okay, you can, because a lot of dams are designed that can be heightened further. But I mean, you know, you can't have it half like this. Dams centralize decision making. There's only one gate. There's one person to decide I open or I close the gate, isn't it? And there may be thousands of individual water users dependent on that water. So it is a centralizing force. I'm not saying that it is good or bad, I'm just observing. It is long-lived. And that is very important. How long is the design life of a dam? Ooh, difficult question. The normal answer is 50 years. So what do you do after 50 years? The first dams we built, we didn't bother to think about that. The beautiful irrigation, the beautiful engineering arrogance. You build something and then it will stand there, and then we will later invent something. So for instance, I think the Hoover Dam, you cannot decommission. Cabora Bassa in Mozambique, a big thing, you cannot decommission. There's no way even to empty it fully. Yeah? So that's scary. And of course, at one moment something will happen. The long-lived nature is also very important, because at one moment a society decides we need this dam. This is not a cheap thing. So you have to get organized. So you want it because of certain benefits that you expect, and that these benefits are framed because of your value system at that time. But if this dam is there since 1974, in this case, Cabora Bassa, we now live 40 years later. Our value system has changed, perhaps. And we have the same dam. Perhaps we would like to modify it because our value system has changed. But how can we modify this thing? And that's the last point. It's inflexible. So all this together creates that we are forced to go with the dam that we have created in some distant path. So we are path dependent. And we have the same in the Netherlands, actually, because we have some hard infrastructure developed in the 1930s, 40s, which is impossible to get rid of. It is such that it even becomes part of the DNA of a country, if it is a big work, like the High Aswan Dam in Egypt, or the Cabora Bassa Dam in Mozambique, or the Afsluitdijk in the Netherlands, the big dike that created a lake, what was formerly the sea. Now, if we know all this, and of course our predecessors have made perhaps some mistakes, or they have made some decisions, but now we are in 2016, and we need more storage, and we know all this, and we know that our value system in 40 years' time will be different from now. What do we do if we need to design for new storage? I think that's not a trivial question. Let's talk about uncertainty a bit. Yeah, some people use the word deep uncertainty. It's very nice to use that word, deep uncertainty. So I use it once. I use it once, but we have to be a bit careful. You know, it is just, we live in an uncertain world. And I will give a few examples. Population. Will we have a world of 9 or 13 billion people? Yeah? Economy, I come to this. Socio-cultural. We've been discussing during the safari about how will our societies look like in 50 years' time. How should we know? We think that we know that it will more or less remain the same. But who says? And we're talking all this climate change, but about these simple things, about how will our socio-cultural system look like in 30, 40, 50 years' time, we prefer not to talk too much about the geopolitical situation, climate, and of course all the surprises that will come, and over which we can say nothing, because then it wouldn't be a surprise. Now, just an example. This is a graph. This is 1990, 2004. And this is another graph, another timeline. Yeah? And then this. Could we have predicted this? It's difficult, eh? So what are these lines? I challenge you guys and girls. What is it? What are these? What do these things represent? These are prices. But of what? Yes, which one? the lower one. And this one? Corn. You call it corn, I call it maize. Now, you know, there's a funny thing that these were completely independent of each other until 2008 or 9, when they started to be coupled. If the price of oil goes above 90 or 80 or whatever dollars a barrel, there's a connection to maize. And why? It's because of the subsidy of the United States for the Midwest farmers, who normally buys up for a guaranteed price the maize from the poor Midwest farmers. And at above 18 or $85, it is more profitable for these farmers to go to the ethanol factory. Yeah? And then you get because what does the government do normally do when they buy the maize from the farmers? They dump it on the world market, leading to an artificial low price. But not when the oil price goes up. And then you see there's, for the first time ever, a connection. I know the situation is more complex than this, but this is definitely an element that you have to take into account. Before 2009, we never, ever thought about these, let's say, these large connections that exist between completely, what we thought of are completely different, unconnected fields. So how can we predict the future, because there may be other connections that we don't see and that will come apparent later. Now, and these, spikes, etc., are more spectacular than all the climate change predictions that you can find. Yeah, putting in perspective the climate. I like this a lot. It took me a long time to find this graph. This is the variation of prices, farm prices for Africans, for maize, corn. So the fluctuations, the annual fluctuations of maize prices are big, which have a huge impact on the livelihoods of people, which makes it unpredictable. Can I invest in my farm or not? If the price is high, of course, but if the price is not high, because perhaps the Americans are subsidizing their Midwest farmers or not. Now we come to climate change. There are some experts in this room on climate change, I guess, and I am not an expert of climate change, so I have to be very careful. This is a nice graph for Southern Africa, and I blew one example up. This graph contains a lot of information. This is the historical variation of the data on temperature and precipitation. So they cluster around 0 temperature change and fraction of precipitation 1. So the historical precipitation floats around the long-term mean, it's obvious. In future, they project an increase in the temperature, and here they have like, I don't know how many runs with different types of climate models, and they also indicate that probably most of these runs indicate that there will be less rainfall in Zimbabwe. So we have a temperature increase, and most of the predictions indicate also that there is a precipitation decrease. And so they made it for all these different things. Another one, they've put it the other way around. This is the World Bank on the Zambezi basin. And then they say, okay, historically, we had so much rainfall per year, and the temperature was like this. And in future, okay, the temperature goes significantly up. Now, and I think we all agree about that. There's no denial of that one. But whether the climate will become wetter or drier or remains the same, we simply don't know. And of course, you can count the dots. There's more dots that on this side, so there will be less rainfall, probably. And then you make a big mistake. Then you think that the points are like a probabilistic distribution. But these points are not probabilistic distributions. They are different types of models that are being run. And we have no clue which model is better than others, and whether they are normally distributed. Why should different models be normally distributed? So we have no clue. That's what we know from this graph. Perhaps some of you don't like this and disagree with me, but so we know it gets warmer in the Zambezi, period. And then you have publications in good climate journals that say exactly the opposite. So there's this Goose and Gaia, who says downscaled global circulation models cannot reproduce important historical rainfall characteristics, such as the number of rain days and wet-dry sequences in a catchment in South Africa, the Umgeni. And this is the co-author is Professor Graham Hewitt, whom I know very well, very renowned hydrologist. And they then conclude, since we don't have the climate data right for the future, we cannot make hydrological models right. Because to predict the blue water flows, we need to have good input data for rainfall, temperature, etc. Yeah? However, Pinto et al., also very renowned scholars, also for the same region, says the global circulation model and the regional circulation models are able to capture the observed climatological spatial patterns of the extreme precipitation in southern Africa. And that is basically saying opposite things. So we don't know. We don't know. If these climate guys and girls don't know it, how can we, as users of this information, know? And this is also another nice graph. This is Casey Brown. He's really a smart person. Check his work. So he found that he puts outcomes from some of these global circulation models and downscaled regional climate models. He put it in a hydrological model, and then he sees that he cannot even reproduce the current scatter, the current variability of the rainfall, of the blue water flows. So he finds that his model, that the variability of flow will be less with climate change. Now everybody knows that that cannot be true. Yeah? Just to show that we have to be a bit careful using our information. And I try to put this in a graph. And I'm not a climate specialist, but I thought let's keep it simple. So the global circulation models have, the A is for surface, spatial scale, have an immense spatial scale. How big? Global circulation models. You have to know this if you want to be part of the Water Institute. Yeah, but what is the spatial resolution? What is the smallest unit?
100 kilometers.
Yes, it's 100 to 300 kilometers. So so we talk about 100 times 100, 10,000 square kilometers to 100,000 square kilometers. Yeah? That's 1 pixel. And what I want to know, you, because you are water guys, what is the flow? How much water do I have in the end? So picture a pixel of Ontario, yeah? So how big is Ontario? 100,000 square kilometers? More, yeah, okay. So there's 2 pixels or so, or 3. And then, so how do you make a hydrological model? You lump everything together, the Grand River and all the other nice, beautiful rivers. You put it all together, and so it doesn't work. So you have to downscale it. So you have to do some hocus pocus to get this large-scale information to a smaller spatial scale. Because what is funny, the temporal scale is 15 minutes of these global circulation models, and they aggregate it to 6 hours and sometimes days. Yeah, but that's the temporal. The temporal dimension is this one, and the spatial is this one. So we are in this corner. But for the Q, I want to be here. The scale that I want is for the temporal, perhaps days. It's good enough. And for the spatial resolution, I want to go to 1 square kilometer, or preferably 1 hectare, 100th of a kilometer. Yeah? Are we together? To have a bit of a good hydrological model. So I have to downscale it from 10,000 to 100,000 to 1/10 of a kilometer square. So that's very difficult. And now they start to realize, a lot of these climates, that by doing this downscaling to regional climate models, actually, they call it bias correction. Okay, there's different methods. One method is bias correction, but by correcting the bias, they introduce a new bias. But they don't know what bias they introduce. So, and they generate inconsistencies, because they violate the mass balance, the conservation of mass law. Because they should actually bias correct and put it back in the global to make sure that everything still sums up to 0, but it doesn't. And then we need temperature, and then we need P, and then once we have this, we can make a model, and then we know how much water is available. You see how many question marks? So actually we don't know what the impact of climate change will be. That's the most honest answer that we can give. And we have to be a bit honest in this. But there's a whole industry that makes a lot of research money out of all this. And then finally, we have huge risks. This is a graph you may have seen from the this year's World Economic Forum, the Davos thing, and it indicated what are the biggest risks of society in terms of likelihood and impact. No surprise, there is water crisis and failure of climate change mitigation and adaptation are in the upper corner. So these are definitely water related. Mitigation of climate is 90% water, as you well know. So, conclusion, we don't know how the future will look like. And yet, our toolbox of dams freezes our solution space for the next 50 to 100 years. So what do? We have to be smart. And we can also say we don't need water storage. Perhaps Canada doesn't need water storage, I don't know. But I know that in Africa, there is a dire need for more water storage because they cannot, most African water systems cannot cope with the current variability. And one thing is likely that the variability in the future of rainfall, temperature, whatever, will increase. So we do need more water storage, especially in Africa, but perhaps elsewhere. Can we find alternatives? Now it becomes fun. Okay, sorry, not yet fun, it is still a bit boring. We need to have, if we have a solution, it must be a robust solution. It should be able to satisfy many different possible futures, correct? So this is a very old-fashioned graph. And now I come with a new term, adaptation pathway, which was developed by a colleague in Delft, Marjolein Haasnoot. And she calls it the metro map. So basically she says, we have to be smart in our investments, and we have to make sure that we don't make the wrong decisions too early. So, okay, I'm not going into detail. She did a very complex one, metro map, for the Netherlands, because the Netherlands faces sea level rise, and we don't know how to solve this. There's different ways of solving it, and the science is not yet clear about everything. So the large investments we have to postpone as long as possible, so that we don't make the wrong investment. But we have to start acting now. So what to do? So she makes these different pathways of going where we want to go. And I can summarize it in this slide. Develop alternative development scenarios, identify possible actions, and their sell-by date, how long do they solve the problem and then become redundant. Identify feasible pathways, then the preferred pathways. Make sure that you postpone the expensive interventions as much as possible and implement the no regrets now. Monitor, 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 and learn in the meantime. Yeah? And I come back to this. I have to be a bit faster. Now it becomes a bit fun for me. What are inspirational examples from nature? Natural storage, ice. And you know that much better than I do. You have plenty of it. Okay, less and less of it, I guess. And this is, which I'm Africa biased, eh? The Kili, the Kili. And also the Kilimanjaro is, the glacier is retreating. And then I was talking to Bruce, and then Bruce says, Pieter. And then I couldn't, sorry, I had to do this.
Beavers are vegetarians. They gnaw through bark to eat the sugary layer underneath. They've been gnawing through forests for 20 million years. Felling trees with your teeth takes great strength, skill, and patience. One technique is to slice halfway through and let the wind do the rest. The pond makes it easier to move around the heavy logs they need to build their dams. Out of the water, it's a struggle. Stones help weigh down the base. The whole family works together, carefully interlocking the timber. They dredge mud from the pond bottom to seal the dam. Each pond traps several inches of sediment every year, so there's plenty of it. The young act as apprentice builders, learning the tricks of the trade. The final results are impressive.
Okay. I want to talk about the Tonle Sap. So that's a natural store. And this is the one but richest wetland in terms of biodiversity in the world after the Amazon. And I think the richest fisheries, freshwater fisheries. Cambodia survives on it. The lake breezes. The basic size is like 15,000 square kilometers or so, and then it's very shallow, and then it goes up 8 meters every year, and then the lake becomes big. And then you know about this benthic stuff and all this. It's a pity Mark is not here. Oh no, Simon is here. So then you know that there's all kinds of food stuff that these animals can eat because it goes up, and then you have all this protein or whatever, and this biodiversity. So this is a natural dam, as it were, store, because when there's a high flow, part of the flow doesn't go to Vietnam, but it goes into Tonle Sap. So this part of the river flows in the high flow season this way, and then after the high flow season, the water is too high here, so it empties again. So this is a part of the river that flows two ways. And this has been so for time immemorial, and there's a big party. And they have the boat races. Now, you have never seen such a thing. Google it, there's not so many films on it, but they have international, from the region, competition, who goes the fastest. Now, you can't believe how fast these go, because they go with the flow, and these boats are like this, and they are 20 meters long, and there's all these guys, and sometimes they have accidents. But this is cultural, because they know how important the reversal of the flow, as it is called, how important it is. Very nice is that there is a Mekong River Commission that regulates the transboundary issues, at least for the four most downstream countries: Thailand, Cambodia, Laos, and Vietnam. China and Myanmar are observers. And they have indicated that the state of the Tonle Sap Lake is like the indicator for the health of the system. And it's the heartbeat. Doom, kadoom, kadoom. How can you kill the heartbeat out of the system? That's not so difficult. You build dams. So in the main stem, there's already quite some dams in the system, but they are now building the Sayaburi, this picture. There's this one, upstream of the capital city of Laos, Vientiane, and they are now also starting to build this one. I forgot the name. Now, you can imagine that if you build large dams upstream, that you attenuate the flow, and that you start to affect the natural rhythm of filling and emptying of the dam. You get the point. And this is let's say a threshold function. So it is like a tipping point, you know. So we're coming close to resilience now, tipping points. But so this is creating a lot of discussions in the region, and it's not an easy one. But okay, but I didn't want to discuss this because this is really dramatic. If you see how many dams they want to build, But there is a natural storage system here which is beautiful and extremely rich. Okay. Now I want to go to my main topic, riverbeds of seasonal rivers. That's what I want to discuss. And these are found in the areas of Africa in 400 to 600 millimeters of rainfall. Let's say the border between the yellow and the green areas on either side of the equator. 30% of the land area. These are the sands rivers, ephemeral rivers, seasonal rivers. These areas, if you have been there, are considered marginal. I call it goat country. So the only thing that lives there is goats and some people who are poor. Yeah? Because they live in a very harsh and fragile environment. And mainly because the lack of water. Let's go there and let's see whether we can make a difference there. So we have just received money for a project working in Ethiopia, in Zimbabwe and Mozambique, on either side of the equator. So it's mirrored, same climate, different culture, of course. Now, a few pictures, a river with some cultivation. They use shallow wells to capture the water that is underneath the riverbed. Here, this is a picture of Mozambique. Everybody knows that there's water in the dry riverbed. You don't have to tell the people. They have always been using it for domestic purposes. The point is, can we upscale it to really productive purposes, agriculture, irrigation, so that people can get out of poverty? Because washing your stuff there keeps you clean, but it won't get you out of poverty. Correct? And a few pictures from Zimbabwe. So this is the type of stuff. 200 meters wide. Dry. Is it dry? No. If you dig a bit, it's our friend here, you see water. And you can even drink it. And then, of course, they have made little projects, vegetable gardens, especially for the women. Because they have to they work together, you know, they do nice little vegetable gardens, good for the vitamins. It's, again, making people healthy, but not rich. This is how it looks like. And what we now want to do, here they use solar. But we now, and this is the second option, to build a dam in the sand. A misnomer is the sand dam. But the sand dam is, of course, not a sand dam, it is an in the sand dam. So you can put a wall in this, in the sand, in the riverbed to keep the water from flowing down, and also by increasing the sediment layer. A little video again.
Alles klar.
Ah ja, sehr gut. Jetzt sieht man, da ist
Die Überflutung ist jetzt vorbei und es
Examples here. This is in Tigray. They built this a few years ago, a sand dam. It's completely filled. And it enhances the water storage. And here another one. This is in Umzingwane. They built this wall. It fills up, but you can see they don't finish it because once it is filled, they build the dam slightly higher again. So they slowly build the coarse sand behind the dam. So they increase storage. And I want to do, okay, sorry. Now we go back to this uncertainty in the future. We need more storage, especially because we have high population growth. But we don't know, perhaps there's low population growth. We need more storage because of a drying climate, but perhaps the climate is going to be wetter, we don't know. We may have a booming economy, then we need more storage. Perhaps the economy is stagnating, and if you combine all this, you either go for very high storage or little storage. You get the point. So there's a lot of uncertainty. What do we do in face of such uncertainty? You can do nothing, which is happening in a lot of African countries, unfortunately. You can just build a huge dam, but then you have to wait because you have to first get the money and all the things in place. You can do an intermediate dam, And you can do all kinds of small dams, like this. Yeah. So this is actually the different. Oh, sorry, you can't see it very well. So these are the different types of options that you can think of. And the question is, which pathway is best to use, which pathway allows best to learn, to build in the process institutional capacity to deal with this infrastructure, with allocation issues, to deal with possible externalities, and with the unknowns. Now, the answer is perhaps a bit obvious, that perhaps this small-scale development is more adaptive than anything. And now I want to give an example. Imagine this part of the picture is an above view of a river. This is the dry riverbed, and these are the sides. Sorry, my qualities of a cartoonist is very limited. And in this case, there's two villages on either side. They get drinking water out of the river, and there's a community gardens for the ladies, as I indicated. And that's how it is now. Now, what we want to do is the following. Okay, this is the current situation. Comes a flood, it fills the riverbed. Then the first half meter evaporates, and the rest stays, flows slowly downstream. The capacity, 50,000 cubic meter, if you take a stretch of 500 meters by 200 meters. Now, what can you do with this capacity of 50,000? You can add a vegetable garden. You can add now real plots where you can make money. And then you say, okay, now the water gets a bit potentially scarcer. Now we have to make sure that there is symmetry in information, so everybody should be able to see how much water is still left, so that we can take action if the water is short. I will come back to this. And we can increase let's say the utilization of this store. We can build a sand dam in it. If the pressure continues, this will then, look at my cartoon, it will increase the storage. You get the point, because of siltation. And you can continue. And basically what you can do is you can green. We've calculated in this example 50 meters on either side this farming, irrigated farming. So you can lift these people out of poverty if you want. And it will be adaptive, and it will be one big learning exercise, and it will take time. Okay, community monitoring device. We go back to my country, Holland, and my wife. So we were walking on the peatlands, and the peatlands, they are rehabilitating the peatlands because they were drained, and now they want to restore them. And the trick is to keep the groundwater levels high. And now they have a community gauge. You see that? It's just a simple thing, a tube that floats on the water, and the target is, the water level is this one, in the green area. So the water level, the groundwater is still too low. This is what I'm going to build, is the community. So that it is crystal clear how much water there is, and that's a necessary but not sufficient condition for managing a common pool. In conclusion, so the adaptive investment pathways is an approach that consciously plans an intended cumulative impact. And that insight came from my safari, because you guys in the Grand River Safari were looking at the cumulative impact ex post. But what I want to do is to do it ex ante. So make steps so that in the end you have the intended cumulative impact. So that is the learning from what we've done in the past, and now make it more consciously. Most of the world needs more storage. But what type? Now, and then this is what I already said. The conventional dams is hard, instantaneous, centralizing, long-lived, inflexible. Nature-based storage is less hard. I don't know how else to say it. It is gradual. It is distributed. It is not centralized. It can be easily decommissioned, and it's more flexible. And it is less invasive and violent. Large dams, an economist will say, is cheap per unit of storage. Economies of scale. It's true. But it is a once-off investment. And in that sense, it is expensive. This is not cheap, but the investments are postponed. So in that sense, if you have a small discount rate, then this one is perhaps better. This is attractive for ribbon cutters, policymakers, but also bankers and engineers. They love it, the large dams. This is perhaps more attractive to communities. The nature-based storage development requires a strong engagement of users and user-based monitoring based on respect for nature and an interest in how does nature work. Based on learning by doing, taking small but significant steps, may only work in certain countries, in certain regions. It's not a panacea, that's not what I'm saying. But in arid, semi-arid Africa, it has the potential to green the banks of dry rivers and bring prosperity to so-called marginal land. And interestingly, it has similarities with room for the river and working with nature approaches. 2 last slides. And this is what Larry wants to see, but he is busy with some other things. The sand motor, which is a very misnomer, sand engine. This is how we want to defend our country against sea level rise. We used to heighten the dunes. And then one smart guy says, why don't we put a lot of sand in front of the coast and let the currents do the rest? And that's much cheaper. So eventually, this will be distributed evenly across the entire coast and heightening and defending ourselves against sea level rise. And this is an even more smart one. This is for Bangladesh, where they are consciously working on increasing the mangroves. And the mangroves are living things. So if the sea level rise, they will also rise. So there is no problem. So that's a very smart thing. And the last slide. If water is running, make it walk. If water is walking, make it stand. If water is standing, make it sit. If water is sitting, make it sleep. Slowing the flow is adding value. And this is coming from the Upanishad. This is the Hindu philosophy. And if you have questions, then I refer to Nandita. Thank you very much.
Thanks very much, Pieter, for an as always, inspiring and provocative talk. How much time do we have, Kevin? Do we go till 10 minutes or so? Okay, so this feeds into to the cloud wherever we're going. We're being broadcast live. So if you have a question, I have to be like Oprah and walk over to you and get this to you. So who has a question? And please don't be intimidated by Pieter. Give him as good as he gave us.
Great talk, Pieter. Thank you. Just a quick question on, I'm an engineer, so I like to ask this kind of silly questions. What's the difference between these conventional dams and the natural dams in terms of affecting, say, greenhouse gas emissions or saving, or in which way they affect, whether they are positive, negative, large differences? Anyone knows that?
Refer to the sand dams, in the sand dams. So the exposure of water to the air is very limited. Just the first 50 centimeters, which is like divided by 4, is like the first 100 millimeters will evaporate, and then it will stop. I think the impact is it must be very limited. Perhaps the impact is the production of cement for the concrete that you build.
So it stays there, and also soil can absorb more.
Yeah, I guess.
That's the new theory, isn't it? The soils can be a better absorber than anything we can build.
Yeah, and if we increase in the process also the organic matter in the soils, of course we sequester more carbon. Although in these climates, a lot of the organic matter volatilizes because of the heat. So it's very difficult to build up a lot of organic matter in these soils.
Great talk, thanks, Pieter. Just with the natural storage as opposed to large dams and whatnot. So you said large dams are more centralized. They can be just an on and off switch or on and off door. But with natural storage, it's more community driven. It's more decentralized. Do you think that this will make it harder to regulate?
Very good question. That's why it is so important to have a monitoring device and symmetry of information, that you make sure that everybody has exactly the same information and understands that it is reliable information. Without that, you run into severe trouble. I agree. So it is more a community-based approach. I don't know if that one is better than that an engineer thinks for us to decide how to allocate the water equally or not to the rest of the community. So these are not easy things, but what I think is that we can learn, and by building slowly the experience of this development and monitoring, so it may take 10 years or so, like the example I gave, I hope that you build this capacity to deal with this issue. But perhaps it's not a convincing answer, but it's the best as I can.
Pieter, I really enjoyed your talk, but I have a question about this idea of lifting people out of poverty. I'm wondering if somebody on your team is connecting some of the dots about how increased irrigation will lift people out of poverty. So how are we building the markets? How are we developing the institutions? How are we addressing who benefits and who loses? I mean, all these unfortunate questions that we probably have to answer, if the technique works.
Excellent question, and I fully agree. So, I was rushing a bit, so I didn't have time, but what we are trying to do, okay, when I studied irrigation, I thought, okay, we bring irrigation to Africa and then everything will be solved. Now I know you have to start at the other end, start with markets. So what is your market? So in our project, we have also the private sector, we try to involve, and government, NGOs, farmer groups, and academia. And we try to do these type of things. So one of the ideas is to go to some supermarkets, because, for instance, in Zimbabwe, in Bulawayo, southern Zimbabwe, 90% of all the stuff comes from South Africa, hard currency. And Zimbabwe is currently again in a crisis. So if we can source it, if these supermarkets can source stuff locally, it's now becoming very attractive. So that is what we would like to seek, to see whether we can establish these market linkages. That you will get uneven development is evident. There will be some who will gain more than others. But now everybody suffers and they have, excusez le mot, shitty lives in these areas. And something has to happen. We cannot do more of the same. So it will not be a smooth process, I fear. So there will be winners and there will be, not losers, I would say, because they will just remain the same. But we have to take risks, otherwise nothing will change. Hey, some people say, if you do what you did, you get what you got. So, and that's what we don't.
Pieter, excellent talk. Really enjoyed it. I had one quick question about, it's kind of along the lines of the regulation question. So when you have a lot of these small-scale solutions propping up, there is a downstream impact because the water's going somewhere. So how do you, on one hand, and I believe in decentralized storage, but there needs to be some kind of organizational structure at some scale for it to be functioning effectively. How do you go about doing that?
So actually what you do these are like spades of water that come through. And so these stores of the riverbed, they fill when there's a lot of water, when there's a rainstorm. So actually, that water is useless if you can't store it. Now, you can store it in a big dam, and it's happening downstream. But actually, what we are doing with this technology is you store it, but perhaps not even 1% of the flow. So if you have many of these things, of course there will be a cumulative impact, but it is not so very big. The big criticism you could have is, actually, if you look at this photo, I hope I can quickly actually we may have an ecological impact. We will compete because these guys, the riparian vegetation, is using this groundwater. So that is where the competition, I think, most is. And then we have to sacrifice perhaps some ecology for some livelihoods, I guess.
There's a question back here, but that reminds me, Pieter, in the Okavango Delta, when Piotr Wolski used to say, we just must pump the water, because if we don't use it, the trees are going to use it. Yeah.
Really appreciated having you on the Grand River Safari. It was wonderful. I just had a quick question about the geomorphology and how the sand dams modify that. It seems like if you're capturing sediment behind the dam, you're decreasing the cross-sectional area of the river and perhaps increasing the risk of flooding. Is that being addressed at all?
Very good point. So we went to Ethiopia. This is what they had built. This was not a smart. This is much too big. You have to make small dams and make it 10 centimeters at a time. Indeed, they had to build this wall, if you look carefully, because they had flooding. And these are farmers here, so they didn't know what they were doing. And you have to. That's what I learned from these. Now, intervening with nature is a hazard. You have to have a lot of respect for nature. And don't modify too much. Start small and learn. And then you will know, and monitor. And then you will know how it works. So this was actually a mistake. It was much too big. They could have done this in stages in perhaps 10 years. It's a good point.
Okay, we'll take one last question.
Thank you, and that's a very great presentation. I really enjoyed it. I just also wanted to find out if there's someone in your team who is connecting the dots with regards to, let's say, prevalence of malaria, because as you construct more dams, whether nature-based or what kind of dams, you are likely to have other unintended health consequences. Are you guys monitoring that and how you can mitigate some of those challenges going into the future?
I plead guilty here. We don't have someone on the team looking at health. But we work with local universities and staff. So we are having this massive amount of master students from the university, from NUST, National University of Scientific Technology in Zimbabwe, University of Zimbabwe, Mekelle University in Mekelle in northern Ethiopia, Eduardo Montana University. So these are like what we call them A4 labs, arid, African agriculture, aquifers, whatever. So these are labs. So we can do anything here. So if there's a student or a lecturer who says, okay, perhaps this has health impacts, negative or positive, we can do that. So that's a good suggestion.
Okay, so that brings us to the end of this. Before we thank Pieter, I have a couple of announcements. One is that this should go over quite well, that there's a reception over at the Grad House now, where there'll be food and non-alcoholic beverages available. Alcohol, of course, is up to you. Sorry, Pieter. So you're all welcome, more than welcome to join as guests of the Water Institute at the Grad House, upstairs at the Grad House. Second is to announce the next talk, which will happen on Wednesday, the 19th of October at 2:30 p.m. It will be by Meryl Ann Fair, the Executive Director and Legal Counsel at the Center for Indigenous Environmental Resources. And her talk will be about water co-governance and collaborative consent, working in partnership with Indigenous peoples to protect water and honor the UN Declaration on the Rights of Indigenous Peoples. Now, that will be, I think we'll have a full house for that one as well. Great topic. So, that brings us to a conclusion, my dear friend. And on behalf of the Water Institute, let me thank you for coming. Here's a small token that can go in your carry-on luggage. And everybody, please. Cheers, buddy.